All right, here's a problem where we're going to solve this quadratic equation using the complete the square method. So we're going to complete the square and then ultimately solve for x, find all of the solutions. So step one is to isolate the x squared and negative 7x terms. So we're just going to add 44 to both sides. The reason we're doing that is because 44 does not complete the square. What do I mean by complete the square? Well, you could check to see if you have a perfect square trinomial. Okay, a perfect square trinomial is one that can be written as a perfect square factorization. One repeated binomial factor squared. And so this is something that's unique. And I know that negative 44 is not the square of half of the b term. So keep your eye on the b term here. If you cut it in half and square it, you should get the constant. And here we don't. So we start by moving that over with addition. That gives us 42. And now we go into the process of completing the square. So take half the b term, so negative 7 halves, and square that. And that'll generate the necessary constant, which will be 49 fourths. So you're simply squaring the top of the fraction, the bottom of the fraction. And since we're adding that to the left side of the equation, an equal sign still means something. So we have to add that to both sides of the equation. So 49 fourths gets added also on the right. Now, the reason this is a great technique is because we can take this engineered trinomial, something we kind of forced to look a certain way, and we can rewrite it as a perfect square binomial factorization. So this will be x, and it'll be minus because we have a negative b term here. So minus, and then half of that b term was 7 halves. We see that term come back for the factorization. Okay, the next step is taking a look at what we get from adding these two constants together. Now you could do that in your calculator real quick or however you want, and you get 54.25. But we're going to strive to keep fractions, reduced fractions. And I know this is not the worst decimal in the world, but here's what you'll see. In your TI-84, if you get this decimal answer from adding these two numbers, immediately hit the math button, which is just below the alpha key on the left side towards the top, and then follow that up with hitting enter twice. So math, enter, enter on a TI-84 plus. I believe this works on a TI-83 as well. What that does in the math menu, it'll grab the first option, which is the fraction conversion tool, and then hitting enter a second time will execute that command and convert your last decimal to a reduced fraction that is 217 over 4. Okay? All right, so now that is the number that we write on the side over here. This is 217 quarters. And you'll see why it's important to keep fractions as we get to this next step now. So now that we have it in factored form, we're pretty much done with the CtS method in terms of completing the square and getting the factored form. Now we need to solve for x. X is nestled away in this expression here, and so we just need to undo the squaring. And that's easy to do with square roots. So we're going to square root both sides, again to keep it fair, keep it equal. Treat both sides that way. That will reduce off the squared operational layer and leave us with just x minus 7 halves on the left. Now over here on the right, 217 is a pretty gnarly number, so I'm just going to leave that in the radical upstairs. Anytime you have a radical of a fraction, you can rewrite that as a fraction built out of the two radicals. So this is where putting it back in fraction mode kind of helps, because now I can see that the square root of 4 is actually going to be a pretty nice number in the denominator. Never mind that 217 in the numerator. That'll be what it's going to be, but for now we've got a nice denominator. Okay, last step really is to add 7 halves to both sides. So now we have a positive 7 halves in the front here. Cannot really combine that without going to an approximation decimal mode. So we're going to stop right here with 7/2 plus or minus root 217 divided by 2. That is an exact answer, and that would be perfectly good for a quiz this time of year if you came across a problem like this.